We want to determine the real solutions to the system of nonlinear equations. This system is x squared plus y squared equals 4, x squared plus y plus 1 squared equals 9. Now before we get started on solving, I want to have a visual representation, and I can tell by the format of this equation that they are both circles. The equation of a circle is x minus h squared plus y minus k squared equals r squared, where the ordered pair hk is the center and r is the radius. Both equations follow that format, so we have a circle which has a center of 0, 0 and a radius of 2. And then we have another circle, and this one has a center of 0, negative 1 with a radius of 3. So if we sketch two circles, we can get an idea of what the solution would be. These circles are pretty easy to draw. Normally I would just draw a sketch, but a circle centered at 0, 0 with radius 2, and a circle centered at 0, negative 1 with radius 3. So I plot the center at 0, negative 1, and I'm going to go 3 away from that, down, 3 to the right, 3 up, 3 to the left, and you get this circle here. I probably didn't do the best job of drawing that circle. It looks like to me that they're going to intersect in one point right here, which is the ordered pair 0, 2. But if we draw some other circles, it's possible for the circles to intersect in 2 points as well. And it's also possible for them to intersect in no points. So we could have no solution, 2 solutions, or 1 solution. So I'm guessing that this is the solution, but we're going to solve it using algebraic techniques. And that's with either substitution or elimination. So let's try elimination this time. I'm choosing elimination because as I look at this, my x squareds are lined up, even though it's kind of off stacking there a little bit. My y terms are lined up. Most importantly, the equal sign is lined up. And then I also have my constants lined up. So this problem is really set up for the elimination to work pretty easily. So what we can do, once we get everything lined up, we want to make sure that when we add the equations together, one of the variables is going to eliminate. In order for a variable to eliminate, you need to have like terms. And we have like terms with the x's. With the y's, we do have like terms, but because we would have to multiply this out, you would have one term that has a y squared and another term that has a y, and so you won't be able to eliminate the y's completely. So we have to eliminate the x's. These x's already have the same coefficient. Both of them have a coefficient of 1. When we add these equations together, we need the variable to eliminate, and that means we need to have one with a positive 1 and one with a negative 1. So I'm going to multiply by a negative onto the left and right side of the second equation. That's going to give me a new system of x squared plus y squared equals 4. negative x squared minus y plus 1 squared equals negative 9. Now when we add the equations together, the x's will eliminate. The y's will write out as y squared minus y plus 1 squared, and 4 minus 9 is negative 5. So we've successfully eliminated one of the variables, that variable being x, and now we need to solve the remaining equation. So I need to multiply out the y plus 1 squared, that's y plus 1 times y plus 1 equals negative 5. When we multiply out y plus 1 times y plus 1, we would have y squared plus y plus y plus 1 equals negative 5. I have y squared minus y squared minus, that's a plus 2y plus 1 equals negative 5. Negative to get y squared minus 2y minus 1 equals negative 5. The y squareds cancel each other out, leaving me with negative 2y minus 1 equals negative 5. So now that the y squareds are gone, this is a linear equation. And to solve a linear equation, we try to get the variable by itself on one side. I'm going to add 1 to both sides to get negative 2y equals negative 4. I'll divide both sides by negative 2 to isolate that y, and that leaves me with a positive 2. So remember that solutions to these systems of equations are going to be ordered pairs. And we've already got the y coordinate being 2. We want to find the x coordinate. So I'll use that first equation. That first equation is x squared plus y squared equals 4. And let's substitute that y of 2 into the equation. That's x squared plus 2 squared equals 4. X squared plus 4 equals 4. And I subtract 4 from each side, I have x squared equals 0. And when we square root both sides, we'll get the solution of x equals 0. So the solution to this system is the ordered pair 0, 2. Thank you for checking out my videos. Have a great day.